Okay, so here we are looking at Georgia riding a Ferris wheel when she is at the top of the ride. Okay, we're going to look at a force diagram. So the force is exerted on her. The center of the circle is down, so you're going to have the seat pushing her up, and then you're going to have the earth pulling her down. The earth will be greater than that of the seat because her change in velocity will be pointing down. Now, if you are wondering how that we arrive to that, if you look at the initial velocity going into the top of the curve is going to point up to the left, and coming out of that curve is pointing down to the right. So your change in velocity is going to be your final velocity minus your initial velocity. So our final velocity points down and to the left, and then our negative initial velocity will point down and to the right. And your change in velocity, or our acceleration, in this case our centripetal acceleration, will point down. Okay, so they're asking for us to find the speed. So here the speed is going to be the distance traveled over the time, and the distance around a circle is 2 pi r over the time. So this is going to be 6.28 times a radius of 10 meters divided by 15 seconds will equal 4.2 meters. 4.2 meters per second. All right. Once we have this, they're asking us to determine the force exerted. They're asking us to determine the force exerted of the seat on Georgia. So here we set up Newton's second law. We have the force of the seat pointing up minus